Hi students, this is Alex here. In this video, we are going to find the Fourier series of periodicity 2 pi for the given function f of x. And this f of x is having four part of the function, that is pi plus x when it is from minus pi less than or equal to x less than or equal to pi by 2, then minus x for minus pi by 2 less than or equal to x less than or equal to 0, and dx for 0 less than or equal to x less than or equal to pi by 2, and pi minus x for pi by 2 less than or equal to x less than or equal to pi. Now let's take the first two part of the function as g1 of x. So that is, it is pi plus x minus x, and the second g2 of x as the last two part, which is x and pi minus x. If I take g1 of minus x, every x is replaced as minus x. So first term becomes pi minus x, and there is already minus here, so it becomes plus, and exactly we are getting pi minus x and x here. So when I take g1 of minus x, I am getting g2 of x. It means it is an even function. F of x is an even function. So we found f of x is an even function. It means bn becomes 0, and we have to find a0 and an alone. So let's find a0. The formula is 2 by pi integral 0 to pi f of x dx. And again this is 2 by pi integral 0 to pi. We have two part here. One is from 0 to pi by 2 and pi by 2 to pi. So for 0 to pi by 2, it is x. So we take x here, dx, and the limit is from 0 to pi by 2. And the second part is plus 2 by pi integral pi by 2 to pi. And here pi by 2 to pi, the function is pi minus x. So pi minus x dx. Now when I integrate this x, this becomes x square by 2, and we have the limit from 0 to pi by 2. When I integrate the second part, pi is a constant, so its integration pi x, and x integration is x square by 2, and we have pi by 2 till pi. Now this is 2 by pi, and even this 2 can be taken outside. We left with only x square. So if I substitute the upper limit, it is pi square by 4 minus 0 plus 2 by pi. When I put the upper limit, pi into pi square, and this is pi square by 2. When I put the lower limit, pi into pi by 2 minus pi square by 4, and already there is 2, so it is pi square by 8. So we completed the upper limit minus lower limit. Now this is, after cancelling this, we left with 1 by pi into pi square by 4 plus 2 by pi, and this is pi square minus pi square by 2. After taking this minus inside, it is pi square by 2 again, and last term will be plus pi square by 8. Now this becomes pi by 4 plus 2 by pi, and these two, when I take LCM, minus 2 pi square by 2, after cancelling minus pi square. So pi square and minus pi square gets cancelled. We left with pi square by 8 alone. We can cancel these two, and we can cancel these two. So finally we have pi by 4 plus pi by 4. By taking LCM, it is 2 pi by 4, and this is pi by 2. Therefore the value of a0 is pi by 2. So we got a0. Now we are going to find an. An, the formula is an equal to 2 by pi integral 0 to pi f of x into cos nx dx. So this is 2 by pi integral 0 to pi by 2. Because 0 to pi, we have two part, and first part 0 to pi by 2 is x. So it is x into cos nx dx plus 2 by pi integral pi by 2 to pi, we have f of x, which is pi minus x. So pi minus x into cos nx dx. Now we are going to use the Bernoulli's formula. We take first as u, second as v. So u equal to x and v equal to cos nx. From this I have to find u dash, which is 1, then u double dash, which is 0. V for this integration is sin nx by n, and v2, this integration is minus cos nx by n square. The same way, this is u and v. So here u is pi minus x and v is cos nx, and u dash becomes minus 1 and v1 become sin nx by n, and u double dash becomes 0 and v2 becomes minus cos nx by n square. Now coming to this integration, Bernoulli's formula is uv1 minus u dash v2 plus u double dash v3 minus dot dot dot. It keeps going like this. So coming to the first part, we have 2 by pi. Then we have to apply these set of terms for uv1. So u is x, v1 is sin nx by n, minus u dash is 1, and v2 is minus cos nx. So I take this as plus cos nx by n square, and u double dash is 0. So we can stop here and put the limit, which is 0 to pi by 2. In the same way, plus 2 by pi. Then we have u, which is pi minus x into v1 sin nx by n, then minus, and there is a u dash which is minus 1, and v2 is also minus cos nx by 2, so that becomes positive, and already there is a minus sign outside, so we keep that as cos nx by n square. So we have a limit from pi by 2 till pi. Now coming to the substitution of the limits, we have outside 2 by pi. When I put pi by 2 here, this x becomes pi by 2 sin n pi by 2. So we take sin n pi by 2 by n plus cos n pi by 2 becomes 0, and when I put the lower limit, since there is an x, it is 0, and this becomes minus, actually it is plus 1 by n square. Then coming to the second part, we have outside 2 by pi. When I put pi here, this becomes 0. When I put pi here, minus cos n pi by n square, minus, when I put the lower limit pi by 2 here, pi minus pi by 2 is pi by 2, and again we have sin n pi by 2 by n, and cos n pi by 2 becomes 0. Then finally we have this as 2 by pi, pi sin n pi by 2 by 2n, and this is minus 1 by n square, and 2 by pi we can take totally common, so we keep it outside. We have next term minus cos n pi is minus 1 whole power n by n square, and again this is minus sign, so minus pi sin n pi by 2 by 2n. Here a small correction, when I substitute this pi by 2 for cos nx here and here, we have taken 0. Actually it is not 0, because when I put n as 1, it is 0, but 2 we have a value. So we should write it as it is instead of this 0 in these two places. So I take the term as cos n pi by 2 by n square. Similarly here cos n pi by 2 by n square. So when it comes here, we are taking this 2 by pi common. So we left with this minus and this minus, and this becomes plus. And already here there is one more term. So we get plus 2 times of cos n pi by 2 by n square. Now we see that these two terms are same term with opposite sign, pi sine n pi by 2 by 2n. We can cancel that, and rest of the terms we are going to write as it is. So an is 2 by pi, and let's write this positive term first, 2 cos n pi by 2 by n square. Then these two I can take the minus sign common. So one is the first term and other is minus 1 whole power n, and even here we have by n square. If we want, we can take n square in the denominator common. So finally an is 2 by pi n square 2 cos n pi by 2 minus 1 plus minus 1 whole power n. Now coming to the Fourier series expansion formula, f of x is a0 by 2, and let's keep this separately so that we can substitute in the formula, plus summation n equal to 1 to infinity an cos nx, and summation n is equal to 1 to infinity bn sin nx. Since bn is 0, this term will be totally 0, and rest of the places we are going to substitute the a0 and an. So a0, what we got here is pi by 2, but here it is a0 by 2, so that will become pi by 4 plus summation 1 to infinity. We have summation n is equal to 1 to infinity an. So an is 2 by pi n square, and we have 2 cos n pi by 2 minus of 1 plus minus 1 whole power n into cos nx. So here the constants can be taken outside the summation. So f of x is pi by 4 plus 2 by pi summation n equal to 1 to infinity. After taking this 2 and pi common, we left with 1 by n square and 2 cos n pi by 2 minus of 1 plus minus 1 whole power n into cos nx. Thus we got the required Fourier series expansion formula.